Good afternoon, and thank you for joining us for another segment of the Jane Irrigation training series. I'm Richard Restucia, Vice President of Water Management Solutions for Jane, and we've got a great program for you today. We're going to be talking about micro irrigation maintenance, specifically emission device and drip tape flushing. This becomes a really important subject. Many years back when I first started in irrigation, I would ask people how they felt about micro irrigation or drip irrigation. And every once in a while, I'd get somebody to say, well, I don't really care for it. And I'd say, why? And they say, well, it doesn't work. And then after asking them a few questions, I realized some of the very minor maintenance that they should have been performing, they weren't doing. Maybe they didn't have a filter. I would discover a few things with just a few quick questions. But again, to have things working properly, there is a little maintenance involved. And staying on top of that maintenance is no big deal at all. And we've got Corey Broad with us today to explain that, help explain that for us. This isn't Corey's first time on this program. He does an excellent job explaining technical issues in irrigation. A few years ago, Corey was the Madera County Farm Bureau Agriculturist of the Year. He's a certified crop advisor. He's a certified irrigation designer. He brings a lot to the table when it comes to irrigation and growing. And the thing probably that's the best about Corey in this sense is how much he cares about his customers and how much he wants to help his customers be successful. So Corey, welcome to the show. And I wanted to ask you, a certified crop advisor, what's it take to actually get that certification?
Yeah, no, thank you. And thank you for the kind words and introduction. And maybe while I go into that, I'll kind of jump to slide 2. So I had something a little bit prepared for that. But nonetheless, looking at the CCA certification, which is through the American Society of Agronomy, there's a few different avenues that you can take. You can have a formal education in agronomy and then also some work experience behind that. And then once you've met those requirements, there's 2 exams that you have to pass. There's an international exam, which kind of covers really farming in the general sense and kind of the key crops that you'd think about with maybe like wheat or corn or soybeans that are grown, worldwide. And then also there's a regional exam. So I live in California and work in California. So I fall under the Western region, which would be Arizona and California combined. And then there are certain states that have just their own, but then there's, the Mid-Atlantic region, there's a Western Canadian, there's a few different regions that you fall under. So you take an exam for that as well. And then once you've passed those 2 exams and you've met the necessary education and or work requirements, you submit this really nice packet to the folks at your local board. And then they review that in a 4 to 6 week process. If there's any questions, they may actually interview you and ask you some additional details. And then hopefully all the details are covered, and then you get a really nice certification packet in the mail, and now you're certified and you can use CCA behind your name.
Yeah, that's fabulous, Corey. I wanted to touch on that because I wanted people to understand that it is a pretty significant process. It's not something you just sign up for and send in a check and it's done. So congratulations on that. I want to remind everybody too, today as Corey is going through his presentation, I've got both the Zoom webinar chat as well as the Q&A open. If you've got some questions for Corey, put them in this area, and when appropriate, I'll go ahead and ask them. So listen, Corey, so tell us a little bit about drip and emission flushing.
Absolutely. So I think kind of one of the biggest things about education when I work with people is you can go through and you can tell anybody why they need or how they need to do something, but explaining why they need to do something I think is impactful as well. And so just as a brief refresher, I know many people on this have probably heard of distribution uniformity or DU and have maybe sat through webinars. I know for my CCA CEU hours, I actually sat through one last week. And it's a very important concept to understand, but basically to break it down, it's a measurement of how uniformly your irrigation water is being applied to your field or your area. And I also think it's important to remember that in many instances, that also means chemicals and or fertilizers. And so we want to make sure we're getting the most efficacy or efficiency out of those products. And so a DU of 1 or 100 is designed And a leading cause of low DU scores is due to the plugging of emission devices in micro irrigation. It's not the only reason, but it's a major contributor. And I find that many California drip irrigation systems operate with a DU of less than 80 or 0.8. And so that's okay, but that means there's also room for improvement. So what we're going to talk about is hopefully a way to improve one of those factors that affects DU. So a roadmap of the kind of what we're going to go over today in kind of correcting drip irrigation plugging. I think it's important to look at the common types of field plugging. I get to see a lot of different things out in the field every day. I cover a large area between Stockton and Bakersfield. So many different water qualities, water districts, et cetera. And then through that, we're going to go and we're going to look at actual emission device and supply line flushing. And then one of the tools that's going to help us figure out how to do that is our Jane irrigation flushing calculator. And then also there's additional technology that's out there to help us make sure we're doing a good job. And the number one thing to remember is, in general, a good irrigation system maintenance program takes a balanced approach. It's not a one size fits all. What works for one field may not even work for the one right next to it. So just remember to look at what we have to offer today, but also consider it may apply in different forms. And so we'll get into some of these details a little bit more specifically. So looking at the common types of field plugging, I tend to kind of break them down into three categories, but there may be more than one issue in a particular field. You can see the picture on the left-hand side. You can see some of the wetting that's come up, and you can see a lot of dry areas. That's definitely not what we want to see. So inorganic plugging is sediment that's debris that has passed through the filtration unit and hasn't been properly flushed out. So that's going to be sand, silts, clays, your soil particles, could even be rocks in some cases. I've seen that, which is always unique. Then going to the organic side of things, that's going to be your living material. So think of algae or bacterias, and those may have passed through in large volumes depending on your filtration unit, but they also may be really small, but over time they've grown because it's living. And so that can obviously be a big issue down the line. And then chemical plugging comes from a precipitation of compounds.
So Corey, I have a question for you here, and that question is, well, when I'm looking at something like this field here, how can I tell what type of plugging I'm getting?
Yeah, so there's a few different ways to go about it. One of the things that I would say is please reach out to me. I'm definitely a resource on this. And then also at Jane Irrigation, we have our lab as well. And so we can help you take photos, kind of dissect your emission devices and kind of understand what's going on. Maybe won't know everything without being at the site itself, but definitely can be a resource in helping you figure those things out. So that's available. And so please reach out. I know we'll be able to share my contact information later. I think it was in the email as well, but I think one of the biggest things is we'll dive into some of the specifics to show some examples, but also please feel free to reach out. So going into inorganic specifically, you want to start by checking that the filtration unit is in proper working condition and that the filtration mesh requirements of your devices are being met. And that really is kind of step one, because if that's not happening and you go and you flush your field, you may just be kind of kicking the can down the road per se. And so even with the best filtration materials, things will pass through, and those debris are generally small enough to make their way outside of the emission device, but bridging can occur. So if you see the photo on the left-hand side, there's a dripper there, and we've peeled back some of the layers to it, but you can see a few different pieces of soil or some type of inorganic material that have bridged together and stuck in between the teeth and the flow path, and that's now blocking it. When bridging occurs, it's really difficult to remove, and you may end up actually having to replace that device. And that could be because, again, maybe the filtration unit wasn't working properly or sized properly, or could be due to a lack of flushing out materials that have built up inside the emitter line. Continuing with inorganic, outlet plugging and drip tape is commonly attributed to soil ingestion. As you can see in the top left-hand picture there, we've cut back an area on an emitter that actually has a flap built into it that is supposed to stop suck back or soil ingestion. but you can see here that didn't really work as there's a ton of material inside the outlet area of the emitter. So a proper air vent sizing and placement is a mitigation strategy for this type of plugging. If you see plugging in a subsurface drip field at the head end of it or the feeding side of the field, that's generally soil ingestion due to air-water interaction. So that can definitely be a challenge for many growers. Plugging on the inlets, though, to an emission device is actually the best opportunity for remediation via flushing. And that happens in the, as you can see in the bottom left photo there, where the debris is stuck on the inlets. When those debris are on there, proper flushing velocities and duration can help evacuate those materials from the hose because they're just sitting on the face of it. They're not inside the emitter.
So Corey, in that top picture there, you've just taken a knife or something and cut the tubing away so we can see where the emitter is. Is that what we're seeing there?
Exactly. So that would be like the outlet. Traditionally, like we have a hole or a slit outlet depending on our products. This is actually one of our competitors' products that has a flap, which is punched out. And the flap is supposed to stop soil from coming back in. But as you can see, it's not necessarily a preventative strategy to go with. And so, yeah, all we did is we took a scalpel in the lab, held down the tape, and then very carefully, of course, was able to cut back the area and get a high resolution photo.
Yeah, pretty cool shot. Thank you.
Yeah, it was good. And these are some of the things that our QC department has done for us over the years, looking at our products and our competitors. And so these are some of the images that we can help you get along with some of the field visits as well from somebody like myself. So jumping into organic, I think it gets a little bit more challenging to deal with. Again, you want to start by reviewing the filtration site. If it's adequate, then we need to go and implement good flushing practices. And 3 keys to that are velocity, duration, and timing or frequency. We'll go into those in more detail later on. But for now, we know we need to get those met if the filtration unit's working, but we're still seeing organic plugging. Now, if the material's on the outside of the emission device, just like we talked about before in the inorganic part, the easiest task is to perform a proper flush of the supply line or the emission device, but also the subsequent piping systems. Because if it's a living organism that's passed through and it's in your emission device, it's likely in other parts of your irrigation system. So simply just flushing that drip tape line or your supply line may not actually solve the problem because something will grow back later. If it's inside the emission device, like the 2 photos you see here, chemical treatment is going to be very likely. The top photo is actually roots that have made their way in. I think I can use my pointer here. And you can see this is the outlet area. So roots have made their way in and have actually gone back down the emitter flow path and have now started to block that area. That's obviously going to be an issue, and you're probably going to need some type of chemical treatment in order to get that out or maybe even replaced. On the bottom photo where it's kind of circled in red there, you can see some film or biology, if you will, that's kind of growing inside the emitter flow path. And that's definitely something we're probably not going to be able to just to flush out.
Corey, I've always wondered about this, the chemical treatments. Doesn't those chemicals then penetrate your field? Isn't it a problem for your plants?
I think that there's a number of different ways to approach this. And this is where working with your PCA, your CCA, a number of different people is going to be really important, your field reps, because there are times that chlorine is probably a good option to treat a specific issue, but maybe you have a plant that's more sensitive to chlorine than maybe your neighbor does. Or it may be time to look at using acid or looking at all these different things. And you need to make sure that you're getting the right dose, the right rate, right application. And that, like you said, don't pour it on and then have it, fall down into the soil profile and things like that. So these things are very tricky and need to be handled with care and professionalism. But there's definitely a number of ways that you can do it where you won't harm your crop or the environment, but you're also able to protect or remediate any issues in your irrigation system.
Yeah. Okay, great. Thank you.
So this is why it's important. This is something that I got to deal with early on this year. So the left-hand side is something I actually pulled out of a filter. It smelled great, by the way. But
I don't even want to know what that is. That's unbelievable.
Yeah, it wasn't good. It kind of looked like a glove at first, and then we kind of found out it wasn't. So that's something that's living inside the sand media bed of the filters. So even if I go through and I flush the pipes and I flush all of my drip tape and all these different things, you can tell that I'm going to have an issue continually down the road. So that was one that you definitely want to look at. On the right-hand side is actually something that had precipitated and caused an issue inside of a sand media filter as well. You can see some of the grains that are built into it where it basically just cemented inside the filters. So going into chemical, this one I think tends to be the most difficult because the root cause is not necessarily easily identifiable. Where, you know, before, as we saw, we could peel back some layers, we see sediment inside or we see roots inside. This can be very, very difficult. And this precipitation can come from a combination of fertilizers and your water chemistry maybe not agreeing, or even the aeration of your water. So a high pH water would be like an example. Hard water, as we call it, is very common here in the Western US. And so you have high bicarbonates that exist in your water source, and then they end up solidifying. So you see it maybe in showers or sinks or things like that. I also see it a lot in irrigation systems. So most often this type of plugging is going to require some chemical treatment, but it's also going to be found throughout the entire irrigation system. So the top photo, you can see the inside of the emitter is kind of built up with this film or scum. And then on the right-hand side of that dripper inside, you can see some squares, and there's some big ones and there's some small ones. That's because they're starting to get blocked off by this film. And then if you look more closely in the bottom photo, you can see inside the emitter pathway where it's actually setting up inside the emitter as well. Chemical treatment is definitely necessary in this case, but it also may not be effective. I'm letting a video play in the background here that I took a few years ago. And this is a slide that I've used before in other presentations, but flushing needs to be done even if only single season drip tape's being used. So I feel like there's a common misconception a lot of times that I'm using a 5 or a 6 mil tape that maybe only is in the field for 2 to 6 months. And well, I'm going to remove it from the field at the end of the season, so I don't need to spend money on labor doing that. And it still is important that flushing needs to be done at the right frequency, but also the right PSI. Simply opening up the end of those lines for 2 to 5 minutes is not going to be successful. I have the link to our calculator, which I'm going to jump into here in a minute. But again, this is a slide just to kind of illustrate the amount of material that had built up in this line over a single season and started to cause plugging later on. And that's because they said, well, I don't need to protect it because I'm going to get rid of it. Well, you can only push these things so far until they come back to get you.
Yeah, so Corey, I had a question while you were gone, and it was on that chemical treatment. And
Yep.
So what if you try a chemical treatment and it doesn't work? Do you have to pull out sections? What do you do at that point?
Yeah, I think there's a few things. So if you've gone through the process and something has been identified as a root cause, and you can't necessarily correct that with just chemical treatment on its own for remediation, then yeah, likely device replacement will be necessary, which is obviously, you know, a negative impact on your investment and capital costs, et cetera. But nonetheless, I think that in many instances, there's a lot of ways to get ahead of these things. There are many companies out there that can help you with this. And there are so many products that range, again, from acids to chlorines to peroxides in order to help make sure that we're keeping these systems clean. So don't throw your hands up, just make sure you stay the course, but also plan, right? When you're going and you're developing a site or you're developing an irrigation system, get a water quality test done, understand what the constraints are going to be for that irrigation system, and know what challenges you may have ahead of time so you can make sure that your infrastructure or your practices are set up for it.
Yeah, and I just want to be clear too, the percentage of issues that can't be solved is a real small number, right?
I would think so. With the amount of professionals that we have in the industry and the amount of technology that's gone in and chemistries that we have at this point, there's a lot of things that can be, again, I talk about that balanced approach. There's a number of things that can be implemented together in order to still make an irrigation system successful.
Great, thanks.
Yep. So kind of jumping back into some of the specifics, I talked about velocity earlier on. So specifically, velocity of the supply lines needs to be, the flushing needs to be done at a higher velocity than normal. So we generally want to target 1 to 2 feet per second of velocity in your line. So even if your water looks clean, as you can see in the picture on the left-hand side, and the pressure seems high enough, the cleaning action is likely not sufficient. And that comes from a rule of thumb that 60% of your debris in your line is in the first 40% of it lengthwise by weight. So all the fine stuff that you find at the end of the line when you open it up real quick and it's really dirty and then it goes clean and you're like, oh, wow, that was it. That's because a majority of it is actually heavier and has settled out much earlier on in the length of the run. So over time, as stuff continues to settle and build, you actually create more problems in that line. You just don't see it yet. So going through and getting that velocity up in order to pull that material and lift it out is going to be key. Duration, I think this is one of the ones that we miss on a lot. I talked about that 2 to 5 minute earlier. Well, specifically, I see it's commonplace for many row crop growers to send labor through to flush individual tape lines. The picture on the left-hand side is our turbo tape with our NBV09 flush valve. It's made to make flushing less labor intensive as far as having to open it up ends, just make it easier for guys to get through the field. And so what I tend to find is guys will go out there and they'll open up 5 to 15 lines at a time and proceed to walk back and kind of loop around and close them up. Roughly takes about 5 minutes to do it. And this is during a normal irrigation, so not increased pressures and flows. And what we find is that in most California large-scale drip systems, it can take up to 15 minutes to flush a single line of tape, even at a high velocity. So while you're spending the money to go do that, you may not actually be doing it properly. And so you may actually be wasting money in that case and not protecting your investment. Timing or frequency is probably the #1 question I get. How often should I flush? And that answer is going to vary from irrigation system to irrigation system. What is your water quality? How long do you intend to keep the emission device? What are the economic ramifications of flushing versus not flushing? These are all things that somebody like myself can work with you on and discuss, or your irrigation dealer. But these are all the things that need to be taken into consideration when building a flushing or maintenance protocol for your system. An example that I have is I have a grower that uses subsurface drip on processing tomatoes. And they have a protocol that every 2 weeks they flush their irrigation systems during irrigation season. Doesn't matter if it's plugged or not. They found that that keeps them ahead of the curve. And they have some systems that plug up maybe quicker than others, but 2 weeks is where their economic decision comes in and it makes sense for them. And another way growers are working on that is using flush manifolds, and that's going to help limit the labor cost. Here's some pictures of a flush manifold. So what we'll do is on the left-hand side, as you can see, there's a piping system. So this is actually on the downstream end. And so we've connected the tape laterals into IPS risers, just like we did on the feed end of the field. And then it goes into a pipe system that gets buried. And then you can see on the right picture, there's 2 large ball valves. And then what we will do is we will open up these ball valves to flush. Instead of doing one of those rows at a time, we can flush 30 to 40 rows at once.
So Corey, is there any drawbacks to using flush manifolds in an irrigation system?
There's a few conversations that people have had as far as not being able to tell if a line is completely plugged or not, because you're kind of getting this large volume of water at one time out of one valve. But I think honestly, just the biggest thing would be obviously the economic ramifications early on. You have an increased capital cost because you have to do more trenching, you have to do more connections, you have to have all these risers and saddles. But I think if you intend to keep that field for a long time and you pencil it out, they make more sense than you'd realize. And more growers in our area are starting to invest in this.
Excellent.
So jumping into the length of run calculator, I already pre-programmed this in, but I'll kind of show you guys how I got here kind of step by step. And so what I did is these are all just drop-down menus. This is a free piece of technology that's on our website. It's publicly available for everybody. I use it very, very often in product specs. So all I did was select Cascade Thin Wall Emitter Line. I chose a 7/8 inch inside diameter. I chose a 12-inch dripper spacing, and I chose the model as a 0.13 gallon per hour flow rate. I entered in 12 PSI as my starting pressure at the head end of the field. I assumed a flat field, so I didn't enter in any slope. I chose our length of run, which is 1,280 feet. That's very common for us here in the Valley. And then I hit calculate, and now it gives me all these numbers down here that I've started to circle in green. So a 12 PSI beginning, just under 9 at the end. We have an average flow rate of 0.13 down the entire length of run, which is great. That's our nominal spec that we wanted to irrigate off of. our lowest is 0.12, which is just under our nominal spec. That entire length of tape needs 2.72 gallons per minute during irrigation in order to function properly. And our emission uniformity of those devices down that line is 94%. So a lot of really good information just by putting in a few things, and you now have this. Well, now we take it a step further, and at the bottom, there's a flushing portion to this calculator. And you can choose two different things. I started circling this in yellow. So there's a 1.5 foot or a 2 foot per second calculation. I went on the high end, so kind of worst case scenario, and I chose 2 feet per second. I entered in our 1,280 foot run because that's how we're going to flush it. I assumed zero slope again. I hit calculate, and it tells me that I need 28 pounds of pressure at the head end of the field to make sure that I flush this out appropriately at 2 feet per second. We'll remember that. I did another example just quickly on emitter line. So just kind of showing the differences because we have them for our tape products and our heavy wall products. And so I chose our Amnon PC emitter line with a 18 millimeter size, a half gallon, 36-inch dripper flow combo, and then went through, entered in some things. But at the bottom, if you notice, the inlet pressure now is 35, despite being just about half the distance. But it's because the size of that tubing is smaller, so the friction loss in it is greater. So this thing does a lot of information and calculations for you very quickly, so you don't have to do all the math to figure this out. You just know this is what I need to target so that I flush this out appropriately.
Corey, this has been a huge time saver for me, right? And so for all the people who haven't used it, can they just go on our website and type in the search box, run length calculator, something like that, and it will pop up?
Absolutely. It's under our resources tab as well. I think our agriculture tab has it. It's pretty much all over. If you need help using it or have questions, again, you can reach out to me. I'd be happy to walk you through it. It's a very, very valuable piece of technology for us.
Yeah, wow. What a time saver. Thank you.
Absolutely. So kind of going back to the tape side of things where we looked at that 28 PSI. So we know what our requirement is, but does your supply tubing or your tape have the strength to handle that PSI? And that becomes really important as we down gauge wall thickness in drip tapes. So our requirement was 28. In this case, our minimum mill thickness is 13 for this application. As if you see here from our chart from our Cascade technical brochure, a 13 mil can handle up to 28.5 PSI for flushing. So if we say used an 8 mil product, we actually wouldn't be able to flush this product appropriately. And so this is a conversation that growers and dealers need to have when selecting a product. Don't think about, oh, what's the cost per acre of that tape? Maybe I'll go 2 or 3 mil thinner. You might actually have to understand the setup of your system and how you're going to be able to protect that product long term. And every manufacturer has a different number, and every product line tends to have a different number. So you can't just say, well, 28.5 is all 13 mil tape. Not all 13 mil tape is built the same. So I encourage everybody to always look at that and ask those questions when looking at researching drip tape systems or buying drip tape, and making sure that your dealer can answer that for you. So some examples of kind of walking through on the duration side. So it told us how hard to flush, but to simply just kind of understand how long, you take the row length, divide it by the velocity, and you break it down. So as you can see here, a 1,280 foot row length of drip tape at 2 feet per second, like we've been kind of going through, takes just under 11 minutes in order to flush that entire length. So that really bleeds back to that 2 to 5 minutes is not going to cut it. You're not going to be able to evacuate the entire line and all the material that's in it. If you follow the pressure recommendation and you follow the duration, you're going to be in really, really good shape going forward. And then to kind of fall back onto the emitter line conversation and the second example on the bottom, we have a 660 foot row length, a 1.5 foot per second velocity. I changed it up a little bit just to mess with the parameters. And it ends up being just over 7 minutes just to flush that line. So nowhere near the 5 minutes that we've talked about that most people are doing at this point.
Yeah, this helps so much, Corey, because I think a lot of people just think, well, every time I turn it on, everything just accumulates at the end. So if I just open it for a minute, and close it, I'll be okay. But that's not really the case.
Yeah, and it can be very deceiving because you open up the end and you see a lot of stuff come out, and the motor oil turns to chocolate milk, and the chocolate milk turns to, rinse water, and then it's clean. And then you're like, oh, well, that's okay. That's all it took. But then if you wait, all of a sudden you find more material, and then it's clean again. And then you're kind of sitting there going, wow, how much stuff is actually in here? And again, that may not even be at the increased velocity. So yeah, just kind of breaking these things down is kind of how I've learned how to do it over the years. So another important concept when working with your dealer is understanding the flow requirement changes that will happen when flushing. So I put on the top right some equation up there with some parameters around it. If you remember earlier, that line of tape required 2.72 gallons per minute in order to flush. Well, if you go through and you plug in velocities into this equation and use your diameters, that's a 37% increase in flow required in order to achieve that. So now what you have to consider is, does your manifold piping that fed that system and the valves that fed that system, can they handle that additional increase in flow? And that's an important question to understand during the design process, because if you're just designing for normal irrigation conditions, you may not actually be able to get that achieved at the end of your lines. Also, your pumping station and filtration unit needs to be able to handle that if you're going to increase those flow numbers as well. One way that growers are working on the pump side to deal with this is the picture on the left-hand side is the inside of a pump panel that I took. It's a VFD, or variable frequency drive. It's a great unit or tool that basically allows the pump to speed up or slow down when flow and pressure changes. And so it allows you to say, hey, you know what, during normal irrigation, maybe it's running at 80% capacity. And then when it's time to go and I need that 37% increase based on curves, it ramps all the way up and allows you to achieve that. But then once you're done, you can go back to running at like 80% load, which also can save you energy. Technology is one of the game changers for flushing as well. I think being able to understand where to go is really important. One of the big things that I look at is satellite imaging. You can find problem areas before they spread or become more serious. One of the ways we do it here at Jane is through our partnership with AgroLogix. So the image on the top left is our HyperView product, and that's going to be NDVI imaging. And so you can actually see different things going on in the field and plant vigor. So specifically, if you look at the green field there on the top right corner, that's actually the tail end of a planted field. The two red ones actually weren't planted at this time, but you can see at the tail end there where there's starting to be some yellowing going on. And now it gives us an idea of, oh man, is there plugging down there? Or is it a low pressure situation? What's going on? And so very quickly, I can look at that and say, you know what, this is an area that I need to go look at. Or maybe I just go and I just flush that zone or that section without having to go through and flush the entire field. And if I find issues in that zone, they're probably going to be in other zones as well. So it just gives you an idea of where to look very quickly. Another product that they offer as well is our HyperGrow, which is our ETC mapping. So you can see actual crop water use. So you can make sure that it's not necessarily an under irrigation. It is due to plugging or something else. So using these two products in tandem, you can get a really good idea of what your maintenance needs to be. And then of course you can take it a step further in our Jane Logic platforms for technology, which is software and hardware. We put pressure sensors in your field, which can allow you some real insight as to how the system's performing, and then also give you an idea if maintenance is being performed. And then flow meter monitoring is great because you can catch decreased flows as they start to happen set by set. And so you can know, wow, I'm supposed to be running 600 gallons a minute on this set. I'm running 500. Well, what's going on? Well, that's probably likely to be some plugging. Well, let's start back at the filtration unit like we talked about. Oh, my filters are clean. Okay, let's go out to the field and understand what's going on. So that's another way technology can really, it's an investment up front, but it can save you a lot on the back end.
That satellite imaging, Corey, is super cool. And I was wondering if I'm a Jane Logic user now or a subscriber, do I get that satellite imaging now included with the Jane Logic subscription?
Absolutely. So we do 80 acres per full site or full subscription. And then you can add on additionally from that on a per acre basis. But it's a very cost-effective solution. It's detailed enough that you can go make meaningful management decisions based on what you're getting. And it's great because it comes in a few different forms. If you're very used to using our software platform, you can basically just layer it or toggle it off and on in the images you're already in. And then it also feeds into our irrigation scheduler, which is a great tool. But also, if you're simple and you say, you know what, I just want to get an email when these images populate, you can get an email, you click on the image, you can have it right on your phone, and you can say, oh, you know what, we need to go to block 2 and we're going to go look at the south end. So it's very user friendly. You don't need to be a full-on computer whiz in order to use it, but it comes in a few different layers.
Yeah, they're making it easier and easier every day to be a good water manager, right? All these
Absolutely.
at your fingertips. It's really great.
That's the goal.
Yeah.
So if you came late or you said, wow, this guy keeps dropping off, here's the summary page for you. It's pretty simple. Just like to break it down. Number 1, you need to define your plugging. Again, inorganic, organic, chemical, how bad is it? Where is it going on? You need to understand all those things in order to treat it. Then you need to have that flushing protocol. How do you flush? When do you flush? How long do you flush for? Those are some of the calculations you need to do and understand. One of the ways you can do that is using our James length of run calculator. One thing to consider would be importing or installing flush manifolds into your system, or if you have a new project. And then also consider that drip tape thickness like we talked about. Just because the system's laid out a certain way doesn't mean that you can put any drip tape thickness in there. So consider, can it handle the pressure? And then of course, as we talked about, technology assistance, use that satellite imaging to get a view of potential issues. And then also maybe incorporate Jane Logic to view your system performance in real time. You can see what your system is doing from anywhere in the world at any time. And then also last, I'd be remiss if I didn't talk about VFDs. They help you save energy, they can help you flush appropriately, and they can add value to your irrigation system.
Yeah, I love this summary page, Corey, because it really does take a very, and you've done a really good job explaining something that could be a complicated process, but bringing it down basically into 4 steps to follow makes it really easy. Thank you.
Absolutely. So I think that's all we had.
So Corey, fabulous job today. Like I said, you've helped everybody out, make this a simpler process. Like most things in the growing world, it is a matter of setting up process, actually completing the process when you're supposed to, and good things come about. So thank you so much. You did a great presentation today. To our viewers, thank you. Appreciate your patience on a couple technical difficulties, but in the world we're in today, I think we've all experienced them before. And Corey, you did a great job coming back on and doing your troubleshooting. So thank you. Thanks everybody for watching. Hope everybody has a great weekend. Like I said, we are dark next week due to the Irrigation Association's Ag Irrigation Conference, which starts on Thursday. Some of the things that are going to be on there that I really am looking forward to is we're going to have a CEO roundtable. So we're going to be listening to CEOs of the some of the tech players in the irrigation world, including Eric Olson from Jane, talking about what they're seeing in tech and what's happening with irrigation there. And then we've got some other presentations, and towards the end of the day, we're going to have some growers actually come on and talk about the technology they've been using and their success. So should be a really great half day of irrigation technology. Hope to see you guys all next week on that. And then we'll be back here the week after that. So thanks again, Corey. Great